Hi everyone, this is Janine Co, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly. That's why we want to extend our helping hand to you students to stay on top of your studies. And as a result, we are running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, we'll go over Algebra 2. Before anything else, I just wanted to make sure if you can see my screen and you can hear me coming through. Okay, great. So this is where we left off. So I believe we were talking about elimination, and we do have two system of linear equations, right? Yeah. So the question here is we need to solve each system by elimination, right? So as you know, whenever we're trying to eliminate a variable specifically, that means we need to make sure that the coefficient of the variable is the same for both equations, right? So maybe we can take a look at B. So if you have negative 2x plus 8y, which is equal to negative 8, and you have 5x minus 8y is equal to 20, you can actually see right off the bat that you have a coefficient of 8, which is similar to both equations, right? So as a result, all you have to do is maybe if we can just subtract the two equations, right? And see whether we can get rid of or eliminate just the y variable, right? So we would just have x to deal with. Okay, so because this is negative 8y is equal to 20, if you were to subtract the 2, that means if you have the negative sign over here, this would create that positive, right? Because if you're trying to have a negative sign over here, that would be distributed towards negative 8y. Does that make sense? So if you're trying to subtract the two equations, that would turn it into positive 8 as opposed to negative 8 because you do have the negative sign in front of 8, right? So in that case, we can actually just add the two equations, or you can actually just multiply this by negative 1, right? Just so you can get rid of that negative sign. So when you subtract the 2, it's canceled out, right? So maybe we can just multiply this to negative 1. So we would have negative 2x plus 8y. So this is plus 8y, which is equal to negative 8. And as you can see, we can multiply negative 1 to each of the terms. So this would result to negative 5x, and this would be positive 8y, right? So now this 8 is now positive, and you're going to have negative 20. So you're going to subtract the two equations as I mentioned to get rid of that y variable. So as you can see, you have negative 2, negative 5x, so that's negative 2, and this is now plus 5, right? So essentially this would give you 3x, and this is equal to, so negative 8, and you have the negative sign over here, which gets distributed to negative 20, so that's just going to be positive 20 minus 8, and that's equal to 12. So dividing both sides with 3, you're going to get x is equal to 4. And this is positive 4, right? So now we know that x is equal to 4, right? So how do we find y? Well, we're just picking any of our equations. So I'm picking the first equation, which is negative 2x plus 8y is equal to negative 8. And I'm plugging in x is equal to 4 into my x. So therefore, I'm going to get negative 2 times 4 plus 8 y, and this is equal to negative 8. So as a result, you're going to isolate y because that's what we're solving for. So you're going to have 8y, which is equal to, so we know that negative 2 times 4 is negative 8. So negative 8, right, you move that to the opposite side of the equation, you get positive 8. So this is negative 8 plus 8, that's actually equal to 0. So this is, again, we're isolating for y, so you have to divide both sides with 8, so y is equal to 0. Therefore, when they're asking you what's your solution, it would just be 4, 0. which is what we've been doing so far, right? So we're expressing our final answer as a coordinate. Okay, so let's proceed to part C. So we have 2x plus 7y, which is equal to 4, and we have 3x plus 5y, which is equal to negative 5. So as you can see, you can't really see any coefficient just by looking at the two equations that are exactly the same, right? So what did I say about if you have coefficients that are different for both x and y? Well, you need to think of a common multiple, right? And you're going to multiply this with a factor so that you get that common multiple. So just so you're wondering, you can even start with y or x, it doesn't really matter. But to make things simpler, I think if we start by looking at 6x, right? If you try to multiply this to 3, I think it's just easier to multiply it to simple numbers as opposed to larger ones. So that's what I'm doing now. So I'm trying to multiply the first equation by 3 and then the next equation by 2, right? So that I could get 6x. So multiplying the first equation. So when I say first equation, that's like the equation from the top. So that's 2 times 3, so that's 6x, and this is plus, so 7 times 3 is 21y, and that's equal to 12, right? And then for the next equation, when I multiply everything by 2, that means I'm getting 6x, and this is plus 10y, right? Because it's positive 5y times 2, that's going to be 10y, and that's equal to negative 10, because negative 5 times 2 is negative 10. And when you try to subtract the 2, right, you're going to see that 6 minus 6 is actually 0, therefore it cancels out your variable x, right? So all we have left is just y. So you just have 21 minus 10, right? So 21 minus 10 is actually equal to 11, right? And this is 11y, and you have this, so this is 12, and this is positive 10 now, right? So that would be 22, right? 12, and this is minus minus, so that gives you a positive number. So this is 12 plus 10, which is 22. Great, so all we have to do is divide both sides with 11, so you're going to get 2, right? 22 divided by 11 is 2. So now you know that y must be 2. Okay, so once we know that y is equal to 2, all you have to do is pick any of the equations. I can even pick the second equation, right? So you would have to plug in this 2 anytime you see a y, right? So this is 3x plus, so this is 5 times 2, which is equal to negative 5, right? So you would have 3x, and this is plus, so 5 times 2 is going to be 10, right? Yeah, 5 times 2 is 10, and this is equal to negative 5, then you're going to get 3x, which is equal to, so this becomes negative 10, right? Because you're moving that to the opposite side, so you get negative 15 divided by 3, right? So as a result, you're going to see that x is equal to negative 5. So your solution must be negative 5 comma 2. Okay, great. So that's done, and let's proceed to part D. Okay, so for part D, again, you can start with x or y. It doesn't really matter as long as you make sure you find a common multiple between the two, and then you just respectively multiply that with the common factor, right? So if you have 3x plus 7y, which is equal to 15, and you have 5x plus 2y is equal to negative 4, let's say I want to make the coefficient of y the same this time as opposed to x. So I'm taking the first equation, I'm trying to figure out a multiple that's common between 7 and 2, and that would be 14, right? So, and also, just keep in mind that it's not always going to be 14, right? I think just keeping the numbers lower, it's just easier for you to calculate. But again, there's a lot of multiples of 7 and 2, so you don't have to pick 14. Okay, so I'm picking 14 regardless. Okay, so this is times 2, right? And this is basically times 7 to get 14y. So if you look at the first equation, you're going to see that this is 3 times 2, so that's 6x, and this is plus 14y, and this is going to be equal to 30, right? On the other hand, if you're looking at the second equation, you're going to see that 5 times 7 is 35x, And you're going to see that this 2y becomes 14y, and this is equal to negative 28 because negative 4 times 7 is negative 28. So you're trying to subtract the 2, right? And as you can see, 14y minus 14y is actually equal to 0. So all you do is you take 6 minus 35, so that's going to be negative 29x. And this is equal to, so 30, this is now positive 28, so 30 plus 28 is equal to 58, right? So dividing both sides with negative 29. Okay, so 58 divided by negative 29, that's equal to negative 2, right? So x is equal to negative 2. So now you know that x is equal to negative 2, then all you have to do is pick any of your equations, and then you're going to plug in that 2. So I'm picking the first equation, so 3x plus 7y is equal to 15. So 3 times negative 2 plus 7y, so I'm solving for y this time, and then this is equal to 15, right? So 3 times negative 2 is negative 6 plus 7y, and that's equal to 15, right? So as you can see, if we isolate y on just one side of the equation, you're going to see that this is 7y, and this is 15 plus 6. So 15 plus 6 is equal to 21, right? So 21 on this side, and you have 7 to isolate y, you're going to get 21, right, divided by 7. So that's equal to 3. Okay, so that means my solution would be negative 2, comma 3. Okay, great. So I think we've pretty much finished all the questions for this worksheet. Yeah, we did. Okay, great. So we can just move on to the next one. Okay, so now for today's class, right, just to change up what we've been learning so far. So we've talked about, from the previous classes, we've talked about graphing, right? But specifically, we were only looking at just one inequality, right? So now we actually have two inequalities and we need to solve the system, right? And then, yeah, just to give you, I guess, an overview of what we're supposed to be doing for the next couple of minutes. This is basically a combination of graphing two inequalities now, and at the same time, we're going to look at when you're looking for solutions of three equations, right? So three system of linear equations as opposed to two, which is what we've looked so far. Okay, so you have 2x minus y, which is greater than or equal to negative 3, and you have y greater than or equal to negative 1/2 x plus 1. Okay, so the first thing you really do is you need to graph the two equations, and then you're going to see where it overlaps, right? But before that, let's try to graph the following equations first. Okay, so by graphing the two equations, right, I need to have just y on one side of the equation, and then I need to have the slope-intercept form. So maybe I can, let's see. Okay, let's try the first equation. So we know that this is 2x minus y, which is greater than or equal to negative 3, right? So if I were to isolate my y on just one side of the equation, so I'm going to get negative y greater than or equal to, and this is negative 2x minus 3, I'm going to see that this has a negative coefficient, which is negative 1. So as you recall, right, if we're dividing both sides of our equation with a negative number, that means you need to flip the direction of your inequality symbol, right? So as opposed to, okay, let's just do this. So this is divided by negative 1, right? So you're going to see that this is y. And instead of greater than or equal to, this would now be less than or equal to. And for your slope, right, this would then be just positive 2, right? So 2x, and this is positive 3, right? So as you can see, y is now less than or equal to 2x plus 3. And because for the second equation, they've actually written this down in terms of slope-intercept form, then we don't really need to do anything except to graph it, right? So let's go and graph this. Okay, so for your x and y axis, that would be in this black pen. And then Yeah, so the purple pen would be the first equation, right? So this is 2x plus 3. So how do you graph this again? You see that your y-intercept is 3, so you're going to plot that point. So this is 0, comma 3, and then you see that your slope is actually positive 2, right? Therefore, your line has to pass your first quadrant and your third quadrant, right? So maybe we can find, let's see. Yeah, let's try to find your x-intercept. So if you have 0, then you would have less than or equal to 2x. This is plus 3. So this is moving it to the opposite side. You get negative 3, and this is now 2x divided by 2. So x would be greater than or equal to negative 3 over 2. So your x-intercept is actually negative 3 over 2, right? So you're plotting that here. And then on top of that, let's see. Yeah, this is basically your line. Yes, okay, great. So it's now a positive slope. Now let's proceed to the next one. So the next one would be in, let's say, green. Okay, so this is negative 1/2, so you have a y-intercept at 1. Now, because it's a negative slope, therefore it needs to be found in quadrant 2 and quadrant 4, right? So you rise by 1, so that's 2, and then this is run by 1, 2, right? So that's somewhere here, right? Okay, great. So actually, because this is negative 3 over 2, right? And we know that negative 3 over 2 is actually negative 1.5, so it would be somewhere here. Okay, let me see if we can have a straight line over here. Okay, hold on. Okay, great. So we can't really, yeah, apparently this app doesn't give us any line that we can draw, so yeah, you can't have any line. Okay, great. So we're just gonna do this like right now. Okay, so it's just gonna be us manually drawing our line. Okay, great. So as you can see, this is our line. I know it's a little bit crooked, but just deal with it. As long as you know that it's passing through these points, you should be fine. Okay, so remember when we're trying to graph inequalities, right? We had this test point that we were doing just to see which one we're shading, right? So if it's false, that means we don't include a test point. And if it's true, right, we shade the test point, or we include a test point. So that's what we're going to do right now. So we're going to use test points. So if you look at your first equation, which is in the purple line, right, it doesn't really pass through 0, comma 0. So 0, comma 0 is actually a safe test point. So that's what we're going to do now is we're going to test and see if this is true, right? If this statement is true. So we have 0, right? So all you have to do, your x and y, is you plug in the 0. So this is now 2 times 0, and this is plus 3. So as you can see, this 2 times 0 would give you 0, right? And this is 0 less than or equal to 3. So is this true? Yes, right? We can say that 3 is greater than or equal to 0, right? So that's true. So that means if this is true, right, you're going to include this 0, comma 0 over here, right? You're shading that side of your test point. So you're shading this part, right? And then because we still have another line to deal with, which is the green line, So this is negative 1 half x plus 1, right? If we tried to test it out, if you have y less than, or sorry, this is greater than or equal to negative 1 half x, this is plus 1, plug in 0, right? You're going to get 0 plus 1, so this is 0. Can you actually say that 0 is greater than or equal to 1? No, this is false, right? So if this is false, therefore you're not going to include 0 comma 0. Therefore, you're going to shade this part of your inequality, right? And also just remember that if this is greater than or equal, right? So if it's equal and this is also equal, that's why we have a solid line as opposed to a dashed line, if you recall. Because if this is just greater than, then that means your purple line just needs to be in the form of dashes as opposed to a solid line. Okay, so once we figure that out, right, all we have to do is find the overlap of where that shading overlaps, right? So let's color that in yellow. So this is your overlap. Therefore, your solution would be the one highlighted in yellow. Okay, I think that's it for this question. Yeah, so this is your solution, right? The yellow part. So yeah, as you can see, so far, it's very similar to what we've been doing from the previous classes, right? So we were looking at an inequality and we were trying to see where we're going to shade that part of your inequality because of its test point, right? It's all dependent on the test point. So if it's true, therefore we include the test point. If it's not true, right? Well, if it's false, then we shade that other side, which does not include the test point. So because we're dealing with two inequalities, now we're going to get two shading, right? So where they overlap, that's going to be your final solution to solve for the system. Okay, so we have x plus 2y less than or equal to 4, and we have y greater than or equal to negative x minus 1. So the first equation, again, it's not in the slope-intercept form, so you need to rearrange your equation. So when you rearrange the equation, you know that this is 2y, so let's isolate y. This is less than or equal to negative x, and this is going to be plus 4, dividing both sides with 2. So this is y, and this is less than or equal to negative 1 half. This is x, and this is plus 2. So 4 divided by 2 is 2. And then as you can see, for the second equation, because it's already in the form of slope-intercept, that means you don't really need to do anything, right? So let's plot your x and y axis. Okay, so let's start by graphing the first equation, right? So this is actually positive 2, so you have a y-intercept at 2. Then you have negative 1 half, so that means you have your line in quadrant 2 and quadrant 4, right? So that means this negative 1, so you would rise by 1, and then you would have run by 2. So that's somewhere here. Okay, and let's try to find your x-intercept just so it's more accurate. So finding your x-intercept would turn y into 0, so this is 0, and this is basically less than or equal to negative 1 half x, and this is plus 2, so we can just move the 2 to the opposite side of the equation to give us negative 2. Dividing both sides with negative 1 half. So we multiply this with 2, right? Or negative 2. So this is negative 4. So let's see. Okay, this is negative 1 half. Sorry, this is actually positive 4 because, yeah, I just realized this is positive 4. Okay, so negative 2 divided by negative 1 half is actually positive because this negative 2 is also, well, it's still negative, right? So that's why it's positive 4. Okay, now it makes sense. So you have the 4 here. Great. So that means your x-intercept is at 4. So your line should really look like this. Okay, so now let's move on to your second inequality. So your second inequality is also a negative. Yeah, it also has a negative slope, but now it's at -1. That's where your y-intercept is. You run by 1. Okay, so when you're graphing this, it should look something like this. Okay, so that's sort of how your inequality should look like. And on top of that, because you're saying that it's also equal to, therefore it needs to be in a solid line, right? The two inequalities, they need to be in the solid line. That's why you're seeing two solid lines as opposed to dashed lines, because if we're dealing with inequalities, it could also be dashed lines, right? So let's try to use the test point. So as you can see, the 0, 0 is not on the line, therefore you can actually use that as test points. So, okay, maybe we can try. Yeah, so let's try the purple line first because we always start with the first equation. So let's try 0, 0. So if you have 0, 0, that means you would have 0. And then this is so I'm just taking this equation. So this is 0, then less than or equal to -1/2 times 0 plus 2. So we know that this is now going to be 0. So this is 0 less than or equal to 2. So can you actually say that 2 is greater than or equal to 0? True, right? That's always true. That means you're going to shade this part of your inequality, right? The one below that. Okay, and then if you're looking at the green line, right? So the green line, we're going to take this. So this is y, and this is greater than or equal to -x minus 1. So this is 0 greater than or equal to -0 minus 1. Well, this is just -1, right? Okay, so we know that 0 is always going to be greater than or equal to -1, so that's true as well. Therefore, when you're looking at your green line, as you can see, the 0, 0 is over here. That's why this is going to be shaded, this part. Okay, so I guess the overlap would be here, right? And here. Can you guys see that? So this is where the overlap is, right? So that's your solution. Okay, so let's move on to part C. So now we have y less than or equal to 3, right? So we know that if you have y less than or equal to 3, it's supposed to be a horizontal line, right? And then you have y greater than or equal to the absolute value of x minus 1. So if you're looking at the absolute value of x minus 1, right, we know that this is opening up, right? Just because it's a positive coefficient. So this is somewhere here, so this is the 1. Okay, maybe we can keep it consistent because we've been using the green and purple markers. So this is 1 over here. So we know that this is where your vertex is for your absolute value, right? So that's somewhere here. And then we have the y less than or equal to 3. Oh wait, hold on. We're using the purple one for the first equation. Okay, let's graph 3 first. So as you can see, it's a horizontal line, right? So that's y less than or equal to 3, and then we have this x minus 1, and we're taking the absolute value of that. So that's somewhere here. And this is now going to be... Okay, so that's how it should look like. And just so you're interested, right, probably you wanted to know what your y-intercept is, right, for x minus 1. When you plug in 0, and this is minus 1, therefore it should be here, right? So it doesn't really touch your 3 over here, just so you're interested or wondering. Okay, yeah, so we have that. As you can see, your y less than or equal to 3, right? This is if you plug in, let's say, the 0 comma 0, right? Because it's not included. If you have y being 0, right, you can actually say that this is true, right? And if you think about it, right, when you say it's less than 3, that means it's going to be below your line, right? If something is less than 3, that means it's all values, right, including 3. So you're saying that it's 2, 1, -1, -2, so on and so forth. So you're shading the one below, right? And then if you're looking at your green function, right, or well, this is an inequality, right? That means in this case, if you plug in your test point, because your test point doesn't touch the 0 comma 0, so I'm still welcome to use that. So you would have y greater than or equal to, and this is x minus 1. So let's use 0 comma 0 as your test point. So we know that the absolute value of -1 is just going to be 1. And that's 0 greater than or equal to 1. So here's the question, right? Because you know that this is false, right? That means you can't or you cannot shade 0 comma 0, right? So that means you're shading this part. So as you can see, the one that overlaps is basically just this little triangle over here, right? So that's your solution. Okay, great. So we've done until part C, and I believe this is the last question. I mean, the last question for graphing. Okay, so for this question, because your y is now in terms of just greater than or less than, right? It's not equal to, therefore you're not going to have solid lines. It's all going to be dashed lines. So let's graph that. So you would have this and your, so x and y axis, right? I think everyone knows that by now. And let's use the purple one for the first equation. So you know that you have a y-intercept at 1, so that's going here. And you have -1 over 3, so negative slope, therefore it's found in quadrant 2 and quadrant 4, right? So rise by 1, run by 3. So that's somewhere here. And then on top of that, let's say you wanted to find your x-intercept. So if your x-intercept is something that you want to look for the first inequality, all you have to do is plug in 0 for your y. So that would be 0, and this is less than or equal to -1/3 x. And yeah, you can just turn this into -1 because you're moving 1 to the opposite side. So this is -1. Okay, great. Dividing both sides with -1 over 3, right? This would give you +3. So x is equal to 3. So that's your x-intercept. So yeah, that confirms that your graph needs to look something like this. And again, these are basically passing through 0, 1 and 3, 0. Okay, so that's the first graph. The second one, because it's an absolute value function, right? That means we're going to use the green one. Okay, so we have x minus 1. That means we need to translate 1 unit to the right. And we have a vertical stretch by a factor of 2, right? So okay, so let's try to find your y-intercept. So if you have 0, then you have greater than 2x, and this is -2. You move this to the opposite side, so this becomes 2. And this is now divided by 2, you get, so it's 1, right? So basically it touches this and this. Okay, so as you can see, we have this absolute value over here, and we're supposed to check the test point, right? So when you plug in 0, comma 0, because as you can see, 0, comma 0 is something that we can use since it's not exactly on the line, right? It's actually on this origin, right? It's not on the line, therefore we can use that as a test point. So if we're looking at the purple inequality, right? So you have y, and this is less than negative 1 over 3. And guess what? Because it's less than and it's not equal to, that means this needs to be in dashed lines, right? And then for the green one, it's the same thing. Because it's not equal to. Okay, so you have y less than negative 1 over 3 x, and this is plus 1. So our test point would be 0, and you have this over here, which is less than, so negative 1 over 3 times 0 plus 1. So we know that this is going to be 0, and we can actually compare 0, and this is less than 1. So this is actually true, right? So we can say that 1 is going to be greater than 0, right? So when this is true, then that means we can actually shade the test point, right? We can include that. So that's going to be here. And then when you're looking at the green one, if you have 2 and you have the absolute value of x minus 1, so this is y and this is greater than 2 times absolute value of x minus 1. So you would have 0 greater than 2 times absolute value of 0 minus 1. So this becomes positive 1. So 0 greater than 2, right? Is this true? Well, no, right? So this is false. Therefore, you're not going to include the test point, right? So when I say you're not going to include the test point, you're not shading this part. You're shading this part, right? Because you're not supposed to include the test point. So because there is only a little overlap between the first inequality and the second inequality, that means your solution would simply just okay, hold on. So your solution, right, would just be this little triangle over here because, yeah, this is the only point of overlap that they have. And that's why you're not shading here, right? Because we said this was false. Okay, so for the next part, it says, what is the solution of the system x, y, and z? Use elimination. So apparently we have three types of equations here. So first, second, and third, right? So we're used to seeing just two equations, right? And we're probably wondering, okay, so how are you supposed to solve this question, right? So what you can do in this case, you need to label your equations in terms of 1, 2, and 3, just so it's not confusing, and that's what we're going to do right now. So for the first equation, I'm labeling this being the first one. So this is the first equation, this is the second equation, and this is the third equation, right? So whenever you're trying to solve systems using three equations now, you want to make sure you're using two equations, and those two equations need to be in a different pattern. So let's say you're picking 1 and 2, and you're trying to get rid of one of the variables, right? And then for 2 and 3, that means you're getting rid of another variable, right? So you're not supposed to use the same pattern or same, I guess, mix of equations. Like, let's say if you're using 1 and 2, you can't use 1 and 2 again. You need to use a different type of equation. So if you can use 1 and 2, right, you can use 2 and 3. Or you can use 1 and 3. Does that make sense? So that's how you're going to solve this system. So let's say I'm picking equation 1 and 2, right? So in short, right, what I just said, you cannot use repeatedly the same two equations that you've used in the past, right? So if I'm using 1 and 2, I need to find another combination of equations, right? So once I've solved equation 1 and 2 and use that, I can only use 1 and 3 next, or 2 and 3, right? It can never be 1 and 2 again. Otherwise, you can't really solve this system. So if you have equation 1 and 2, right, all you have to do is make sure you write them first. So you see that this is 2x minus y plus z, which is equal to 4. And the second one would be x plus 3y, which is minus z, and that's equal to 11, right? So I guess right off the bat, you can actually see that your z is having a coefficient of 1, right? So you don't really need to do much to it because you want to eliminate just one variable at a time whenever you're trying to use two equations. So that's what you're supposed to do in this case. So, okay, let's see. So yeah, if we want to maybe eliminate z, okay, let's try this. Yeah, so if you want to eliminate z, right, you're going to have that negative sign over here. But think again, right? Because if you're having that negative sign over here, that changes z into a positive sign, right? So you're just simply adding up the two, right? Which doesn't really get rid of z. So in that case, you would have to modify the equation first for the second part so that you would get rid of z, right? That way. So maybe we can multiply this to -1, right? So when we multiply the second equation by -1, that would turn this into positive z. So when we subtract the two equations, that gets rid of z. So let's try that again. So this is 2x minus y, and this is plus z, which is equal to 14. And then this part would be -x minus 3y, and this is positive z, which is equal to -11. And when you subtract the two equations, that gets rid of z. Can you guys see that? And this is now going to be 2 minus x. That's going to be positive 3x. And this is now positive 3y. So 3 minus 1, that's plus 2y. And this is equal to 14 plus 11. So that's going to be 25. Right? Okay, so now you know that you have 3x plus 2y, which is equal to 25, right? So remember what I said, you're going to pick two combinations of equations that should not be repeated, right? So if you're using 1 and 2, I can probably use 1 and 3, right? 2 and 3 is fine too, but because you want to have just x and y, you can pick any, right? You can pick 1 and 3 or 2 and 3. So maybe I'm picking 1 and 3. So this is equation 1 and 3. So I can see from equation 1, this is 2x minus y plus z, which is equal to 4. Equation 3, that's basically 4x plus y minus z, and that's equal to 14, right? So when I subtract the two, again, you need to multiply your second equation, right, with -1 so that when you subtract the two, you get just one variable, right? So I'm going to modify this and multiply this to -1. So just copying what I have for equation 1, that's 2x minus y plus z, and that's equal to 4, right? When I multiply my second equation by -1, I'm going to get -4x, and this is now minus y, and this is now positive z, and that's equal to -14. So I'm subtracting the two equations now. I'm getting 2 plus 4, that's 6x. And then as you can see, you have -y minus y, which gives you 0, right? So luckily, we are able to get rid of two variables simultaneously. But if anything, right, so say for example, you weren't able to get rid of y, right? You were only able to get rid of z, right? That means you're going to set up another elimination equation between this and this. Does that make sense? To solve for x or y, depending on whatever you want to eliminate first. Okay, so now this is done. So we have 4 plus 14 left. So that's going to be 18. Dividing both sides with 6, we get x is equal to positive 3. So now that we know that this is x is equal to positive 3, right, all we have to do is take this equation, since we know that if we plug in just 3 over here, we are able to solve for y, right? So this is essentially 3 times 3 plus 2y, which is equal to 25. So we can say that you would have 9 plus 2y, which is equal to 25. We're going to solve for y, right? So we would have 2y, which is equal to 25 minus 9. So that's 16. Yeah, that's 16. Yeah, it's positive 16 divided by 2, so y is equal to 8. So now that you know that y is equal to 8, right, and you know that x is equal to 3, so the last step would be to find what z is, right? And obviously you need to go back to your original equation and you're going to pick whichever one you prefer. Either equation 1, 2, or 3 is fine, as long as you make sure you plug in your x, your y, and your z. So maybe we can just use equation 1, which is 2x minus y plus z, and that's equal to 4. Okay, just to double check, 2x minus y plus z is equal to 4. So yeah, as I mentioned, we're now solving for z, so all you have to do is plug in 3 whenever you see an x, and you have y, which is just 8. And this is going to be plus z, which is equal to 4, right? So isolating z on one side, we know that this is 2 times 3, so that's 6 minus 8. That's going to be negative 2. Moving that to the opposite side, you would get positive 6, right? Because it's positive 2 and then plus 4, that's 6. Hold on, let's try this again. So we have... Okay, let me just double check this. So we have 3 times 3, 9 plus 2y is equal to 25. So we have 25 minus 9, that's equal to 16 divided by 2, that's 8. Yeah, okay, yeah, as you can see, basically we have this, and 2 times 3, that's 6, minus 8, negative 2, then you have, yeah, it's 6. Okay, great. So our system of equations would just be 3, 8, 6, right? So that's how you're going to solve this question. Okay, great. So I think we've gone through that. Yeah, we said x is equal to 3. Okay. Yeah, so far this is all done. And what else? Okay, so let's move on to the third one. So we're now using substitution, right? So for substitution, this is going to be a combination of elimination and substitution, because substitution you can only get you so much of it. So in that case, we're still using substitution, but it's only going to be the initial part, and then later on we're going to use elimination. So if we have x plus 5y is equal to 9, as you can see, the coefficient of x is just simply 1, therefore we're going to just use that. So we're isolating x on one side, so we get negative 5y plus 9. Okay, so now we can actually substitute x depending on whichever equation we prefer, right? So let's say we're going to use x and substitute that onto our first equation, right? Because we have x and basically we're going to be left with y and z. So I'm using equation 1. Again, you need to label this as 1, 2, and 3. So I'm using equation 1. Yeah, I guess it's just for organization in terms of you want to kind of show that it's equation 1, 2, and 3. So at least you know which equation you're referring to. So I'm picking equation 1, and this is 2, and because I'm seeing x, that's going to be negative 5y plus 9, and this is plus 3y minus 2z, which is equal to negative 1. Okay, so we need to expand and distribute this 2. So this is negative 10y, this is positive 18, this is plus 3y, this is minus 2z, and this is equal to negative 1. So as you can see, we have negative 10 and positive 3. That gives you negative 7y minus 2z, and that's equal to, moving this to the opposite side, you get negative 19. So one equation gives us y and z, right? based off of substituting x into equation 1, right? And since we still need another equation, right, because that's the whole point of solving solutions, right, is to be able to have two equations and then you're going to eliminate them one by one, right? So maybe we can pick equation 3, right, because we're using equation 1 to substitute. So equation 3, here we go. Okay, so we have 4z, and this is minus 5. We know that x is going to be negative 5y plus 9, which is equal to 4. Okay, so let's distribute negative 5 to each of the terms. So this is 4z, and this is positive 25y, and this is minus 45, and this is equal to 4, right? So as you can see, you're going to have, let's organize this into 25y, and this is plus 4z, and this is equal to 45 plus 4, so that's going to be 49. Yeah, 49. Okay, so once we have that and we have this, right? So we either eliminate at this point, or yeah, the reason why I don't want to use the substitution route from this point on is because you're going to have fractions, but maybe we can try that. So let's say we're picking this equation or this equation, and then we're isolating either y or z, right? So I'm using a different pen just so we know that we're doing the next step. Okay, so we're using the green pen. So maybe we can isolate 2z. Okay, let's try to isolate 2z and plug in whatever the c is. So we know that this is negative 7y. And then you move the 19 to the opposite side of the equation, you get 19, and this is equal to 2z. So z is now going to be positive, right? Positive 2. Dividing both sides with 2, you're going to get negative 7 over 2y, and this is now going to be positive 19 over 2, and that's basically equal to z, right? So now that you know that this is z, you're going to plug that in here, right? So obviously, because you know you're substituting z from this equation, you're going to use this equation only once, and then you're taking that z and substituting into this other equation. So you have 25y, and this is plus 4 times z. So z is going to be negative 7 over 2y, and this is plus 19 over 2, right? And that's equal to 49. So obviously, because we only have one variable, therefore we're ready to solve for y. So we would have 25y, and we would have negative 28 over 2. So 28 over 2 is equal to 14. So we can say this is negative 14y. And if we have 19 divided by 2 times 4, that's equal to positive 38, right? So this is positive 38, and that's equal to 49. So as you can see, we have 25 minus 14, so that's equal to 11y. Moving 38 to the opposite side of the equation, we would get 49 minus 38. So 49 minus 38 is actually equal to 11. Dividing both sides with 11, you get y is equal to 1, right? So two options here. If you want to substitute the first few equations, you're fine, right? And then from the step where we're looking at this equation and this equation, some students, they like to eliminate, right? So you can actually think of a common multiple, right? For example, you want to get rid of z first, so you can think of multiplying this equation with 2, so you get 4z, right? And then you eliminate c and you eliminate z, and then you solve for y. So that's one step, right? But what I've done, since we want to apply substitution throughout, right? The only reason why I don't want to use substitution here is because you deal with fractions. So that's why. So, but then again, we want to be able to substitute throughout our way. For this question, therefore we're going to isolate just z, and what I did, because I know that I'm substituting z from this equation, I'm taking z, I'm plugging that into my other equation so that I can just solve for y, right? So once I know that y is equal to 1, I go back to any of my equations. I can even use this or this, but let's say I'm going to use this, right? And then I'm going to solve for z, right? So once I know what z is, I'm going to plug that into my original equation, right? Any would work. Therefore, that's how I'm going to solve for x. So let's say I'm plugging y is equal to 1 back into this equation. So purple, so we would have 25 times 1 plus 4z, that's equal to 49, right? So 49 minus 25, that's equal to 24. So 4z is equal to 24, dividing both sides with 4. I get 24 divided by 4, which is equal to 6, right? So I know z is equal to 6. And then from then on, because I know z is equal to 6, and I know that y is equal to 1, I'm going back to my original equation. So maybe I can use, yeah, you can use any of these, but let's say I'm using this. So I know I'm solving for x, so 2x, and then you have plus 3 times 1 because y is 1. And then you have minus 2 times z, so z was 6. So this is minus 2 times 6, which is equal to negative 1. So as you can see, this is going to be 3 minus 12, right? So 3 minus 12 is equal to negative 9. So you would have 2x, which is equal to negative 1. And this is plus 9, so that's 8. So 2x is equal to positive 8. Dividing both sides with 2, you get x is equal to 4. Therefore, you know that your solution must be 4, comma 1, comma 6. Okay, great. So I think I've covered everything that I wanted so far. Let's see. Yeah, I think that's it for this class. Okay, great. So, to wrap things up, I just wanted to say thank you for attending my class today. If you do have any friends, who wants to learn math during this difficult time, to stay productive and just to stay on top of your studies, please invite them. And if you're interested to see more of our classes, you can actually visit this website. So this is oneclass.com/livestream. So we do classes, not just me, other talented educators as well are on this platform. So we host classes daily, they're free, they're live, and we do math, chemistry, and SAT prep. So we have oneclass.com/livestream to for our schedule, right? So make sure to check that out. And again, yeah, thank you so much for coming in, and I'll see you on my next class. Bye, guys.